This is experiment 2, part 1 procedure, color absorbance, a qualitative investigation for chem inquiry number 7. So what we're interested in here is just sort of qualitatively looking at what happens when light passes through something that is colored. And in this case, we're going to investigate, we have 4 different transition metal ion solutions here. This pinkish red one is cobalt nitrate, the green one is nickel nitrate, the blue one is copper nitrate, and the yellow one is iron nitrate. And to investigate that, we're going to use this other type of spectrometer. It's just like any other spectrometer. It's a homemade device. We call it the tuboscope. And the tuboscope is a long tube. At one end, we have a diffraction grating that we're going to look through. And you can see that if I take it apart. There's a little diffraction grating in there. So just like the boxoscope that you looked at last week, same thing. The difference is that we've just made it a little bit more robust. On the other end is a slit for the light to pass through. So just like any other spectrometer, light enters through the slit and your eyeball is over here looking at what happens when that light passes through and hits the diffraction grating as broken into its component colors. This has one added feature, and that is a little hole on the top. And that is the hole where we are going to insert one of these little vials. And the idea is that the vial only falls down just far enough so that the vial only blocks half of the light, the top half of the light coming in here. And you'll see that more clearly when we show you the next part of the video when we actually do the data collection. But the idea here is that we want the top half of the light coming through the slit to go through the colored solution, and the bottom half is just the regular white light. And when it comes and you look at it with your eye through the diffraction grating, we'll see what has happened to the light that has passed through the colored solution. And for reference, we'll be able to compare that to a full spectrum on the bottom. So we in turn look at every different colored solution. So before you begin this part, you should make your hypothesis on the top of page 16 of Chem Inquiry number 7. You won't be able to get the instructor initials, of course, but make a prediction about what happens in the relationship between observed color of a solution and the wavelengths that are absorbed by that solution. So the question is, if you look at a red solution, is it absorbing red light? Make your hypothesis about that. So what we're looking at now is a visible spectrum that's produced by a white light bulb, and we're observing that white light bulb through the tuboscope, which is just a simple spectrometer that's easily made, but it doesn't have a scale on there for you to make actual quantitative measurements. So we're going to qualitatively look at what happens when we place a vial of the different metal salt solutions that you looked at in the previous part, partially blocking the beam of light that comes from the light bulb. So as these are inserted into the beam, the top half is what you will see after light has passed through the solution, and the bottom half is just for reference. And so you are to record in table number 2 what you see, what parts of the spectrum are absorbed in different metal salt solutions. So first we're going to put in cobalt. So now here comes a vial of cobalt. And so what you can see, hopefully, is that we still see red coming through, but you can notice that all the way from green down to blue, it's completely blocked out. So the conclusion there is that cobalt is absorbing all the wavelengths of light from blue all the way up through kind of a greenish yellow, but it's passing through the red and kind of a pinkish colors, and so of course that's why it looks pink. So you can pause the video and record on your data sheet what colors are absorbed and what colors are transmitted. So the next one we're going to do is copper, which is blue. And so there you can see what colors are absorbed. Pause the video. It's helpful if you might have some marker colors or colored pencils or something like that, but it doesn't have to be. You just mark it into the data table. All right, here comes iron, which is a yellowish orange solution. So here you can see what colors are absorbed by solutions that are that particular color. Pause the video and record that in your data sheet. So the last one is a green solution made by nickel. So you can see the colors, make careful note of the colors that are absorbed. For Chem Inquiry 7, Part 2, Color and Invisible Light Interaction. So what we'll do now, instead of just looking at it with our eye, we are going to actually do some semi-quantitative measurements. And so we're going to make what's called an absorption spectrum. So we can see down here, we've got our metal ion salt solutions in little vials, and then we actually put them in these little rectangular containers that are called cuvettes. And so we've got the 4 colored solutions, and what we want to do is put them into a spectrometer. That's this device right here. It's just a really fancy version of what we've already used in lab, the boxoscope and the tuboscope. The difference is it's got some electronics attached that allows it to record the absorption of the solution at every single wavelength, somewhere between 400 and 700 nanometers. So if I pan up here, we can look at, there is a screen, and Logger Pro is going to record for us when we tell it to. If we put a solution in the spectrometer, it'll graph out the absorbance versus wavelength of that actual solution against this nice background, rainbow background, to help you interpret what colors are absorbed. So before we can get all started, what we have to do is called blanking out the spectrometer. And what that means is we're going to put a solution in the spectrometer that is really just the solvent that all the metal ions are dissolved in. And so what that means is that we are only interested in the light that is absorbed by the metal ions. We're not interested in the light that might be absorbed by the water that the ions are dissolved in. So what we do, we are going to show you here in a minute how to blank this spectrometer so that when we put the blank solution into the spectrometer, it's going to record that and store it, and every time we make a measurement, it's going to subtract the absorbance of the solvent, in this case water, from the reading we get from the solution, so that the only thing that's going to show up on the screen is the absorbance due to the metal ions. So let's go ahead and walk you through how to do that in Logger Pro. So just a few menus. So what we have to do, we just basically are going to tell the spectrometer to calibrate. So it's already warmed up, we skipped that. So we're putting the blank into the spectrometer. And so there, the spectrometer in the background took a spectrum of the water and storing it in its memory. And from now on, every time we make a reading of a different colored solution, it'll just automatically subtract out what happened, what the absorbance was of that solvent, and leave us only with the ion solution. So let's go ahead and do the first one. So here's how it looks like. We just stick that cobalt in there in that spectrometer. We go up and have it take a spectrum, and we'll see it pop up. So let's go ahead and do that. So right there, let's pause for a second and make sure we understand what that means. So as the spectrometer looks at every wavelength from 400 up to even past 700 nanometers, it's mapped on this scale or this background here that you can see. So it looks like for cobalt, in the tuboscope, we saw that we were missing the green part of the spectrum, and we could see the red and the blue. And that's what this graph is showing us, where the most absorbance by the solution is at that peak where it's green. And then where the graph is really low, where the absorbance is low in the purple, blue, and red, that's what our eye sees. And so blue and that red band makes pink. It's really very interesting how your eye works. But this gives us a much more quantitative feel for what the actual absorbance values are for these different solutions. So we're going to go through and just now do the rest of them. And I'll just keep a focus on the screen. So the next one we're going to put in, this is blue copper. These are the wavelengths absorbed by blue copper. So that's is interesting, absorbs a lot in the red. All right, we're going to go to the next one, which is the yellowish orange iron solution. And that absorbs a lot, and blue even goes out into the ultraviolet. And the last one is nickel, which is green. So think about how that looks compared to what cobalt was. So now the next thing that we want to do is on your data table in table number 3, it says to record the lambda max. That is the wavelength at which the most light is observed in the visible spectrum. And we're going to go through, there's a little tool on Logger Pro that allows you to just select which ones are the maximum wavelength. We'll get those up there. And that is data that you need to record. This is Chem Inquiry 7, Experiment 3, Investigations of Nanoparticles. So here we have the solutions set up to be measured in the spectrometer. And you can just see them there for reference. Our 0 had continued to develop over the last few weeks, a little bit different color than we originally started with. So we've actually taken these spectra already. And so let's just take a look at the results real quick, and then you'll be provided with this data. So this is what you're going to be getting a handout of. The data that you have will include the maximum wavelengths. You should refer to that data handout. But we can see there's quite a bit of difference between those different spectra, and they should by now make sense to you in terms of what colors that they are.